This time we're asked to solve using substitution, solving a system of linear equations, that is, two linear equations using substitution. To use substitution, you get y equals something, and then, or you could use x equals something, but I think we're going to use y equals something, it's certainly in this first case. Then you take that and plug it into the second equation. So we're taking this first equation, y equals 2x plus 4, and we're going to use it in the second equation. So negative 2x minus 5, and instead of y, we're going to use 2x plus 4, and then we'll write the rest of the equation out. This is just substituting what I know y is in terms of x into our second equation. I'm going to use the distributive property. So it's negative 5 times 2x, or negative 10x, and then negative 5 times positive 4, or negative 20, equals 4. I'm going to combine like terms. I'll have negative 12x minus 20 equals 4. I'll add 20 to both sides. And finally divide both sides by negative 12. And I get x equals negative 2. Now I take that x equals negative 2, plug it back into my first equation because I also need to know what y is. So back in my first equation, y is equal to 2 times negative 2 plus 4, or y is equal to negative 4 plus 4, or y equals 0. So the point negative 2 comma 0 is the point that makes both of these equations true. And you can double check your work. In my first equation, I'd have 0 equals 2 times negative 2 plus 4. That'd be 0 equals negative 4 plus 4. The first equation checks. And let's check the second equation. Negative 2 times negative 2 minus 5 times 0. Does that equal 4? Negative 2 times negative 2 is positive 4. Negative 5 times 0 is 0. And 4 minus 0 certainly equals 4. So we've done the first one. For this next one, you might want to pause the video and see if you can solve this on your own. What I'm going to do this time is take equation 2 and plug it into equation number 1. So I'll have 2x plus 3, but instead of typing in y, I know that y equals negative 4x plus 10. So I'm going to use negative 4x plus 10 instead of y, and then finish the first equation. I'm again going to use the distributive property. I'm again going to combine like terms on each side of the equation. Then I'll subtract 30 from both sides. And lastly, I'll divide both sides by negative 10, and I get that x is equal to 4. Again, I'll take the answer that I have for x, plug it into equation number 2, and find out what the value for y would be. Negative 4 times 4 is negative 16 plus 10, and that leads to y equaling negative 6, which gives us the point 4 comma negative 6. Alright, so let's do this third one, part C. Let's take this first equation and plug it into the second equation. I have 6x plus 3, and instead of y, I'm going to use negative 2x plus 1, and then I'll finish the second equation. I'm going to use the distributive property. Oops, that's negative 6x plus 3 equals 3. I'll combine like terms, and then I end up with 3 equaling 3 and no x to be seen. That's kind of strange. We've got our first equation in the form y equals something. I'm going to take my second equation and I'm going to solve for y. I'll do that by subtracting 6x from both sides and then dividing both sides by 3. And I get y equals negative 2x plus 1, which is the exact same equation that I had before. That means that I have an infinite number of solutions. That is, no matter what I pick for x, there's nothing I can do that would make 3 not equal to 3. They are exactly the same line, so they land right on top of each other when we graph them. So for this, there's an infinite number of solutions.